Hello everyone, we are the Valley Express Ecosystems group, and our project was to do email signature removal. And this project is mostly a back-end project as it fits in the ecosystems process as the first part. When an email comes into their system, we try to identify the signature and junk data parts and then try to remove them. It then is passed off to their system, which then goes to the email to find important trucking information. We created this GUI here for easier to show and build our training and testing sets. And so without further ado, let's run it. Down here we have the data. You can enter the testing data percentage, so 20% here. We'll let that run. It'll take a couple seconds here. Now we can kind of see the stats here. So here's our three types of accuracy. Our first one is Matthew's correlation coefficient, which we believe is the most accurate measure of our accuracy. And this means we are correctly classifying 94% with 5% incorrect. Our F1 score will be a little bit similar, but a little bit higher. It's a slightly different calculation. Accuracy will be the highest, which is a little bit overinflated due to how accuracy is naturally calculated. If we click on matrix here, we can see the confusion matrix. This is the true amount of true negatives, which is the amount of things that we wanted to keep and we did keep. This is false negatives, things that were actually not supposed to be negative, but we marked them as not as negative. This is false positives, and this is true positives. So stuff we wanted to remove. A couple other statistical measures here. But now let's talk more about the emails here. So down in the system, we can see what is being correctly marked and incorrectly marked. So for example, this email, true negatives, this is important stuff that we want the system to keep. This darker green here is true positives, or signatures that we wanted removed. This is going to be a false negative, so something that we should have removed, but the system missed it. But our sponsor has said things like the names and stuff like that usually are not going to be a big impact for the system. So here's one that could potentially cause problems, a false positive. But usually with emails it's not as big of a deal. We can show all the false positives and see if there's any issues. Here's one example of a false positive that could be dangerous, where we want to necessarily keep that, but there is safeguards later down the line in the system to prevent that. We can also see a list of the false negatives. So now we'll run this with a data set that really hasn't been seen as much. So we train on this previous data set and we test on a brand new set of 200 to kind of show if there's overfitting or not in the system. So the numbers are a little bit lower, but that is because it's training on a new system, a new set of we train on the old existing system and test on a new system set of data to make sure that's not running into any overfitting issues. So here are the three statistical measures. It's always really good to see what's being popped up in the false negatives column here and the false positives. We can also see here the overall accuracy for any given email. And so most of them trend in very good numbers here, but there's a couple that kind of dip down in those kind of edge cases. But overall, this is our system. In terms of what our sponsor will get, is they will get really the back-end conditions that we've kind of created for them, and then that will go into his system, which, like I said, it will be the first part, which does a lot of the signature removal. Then it will go on to his part, which will then look for important trucking locations, such as this one. And then it will move on and then automatically put those trucking locations like that in a database. That is our project, and thank you for watching.